Welcome, my friends. In this video, we will be discussing Pearson's coefficient of skewness, but we will begin by explaining what skewness means using graphs of distributions. A symmetric distribution like this one here is not skewed. The mean and median are both the same. The mode is also typically the same as the mean and the median in a symmetric distribution, but since the mode isn't commonly used, we will exclude it from our discussion. A distribution that looks like this one, with its tail to the left, is called a left-skewed or negatively skewed distribution. In a skewed distribution, the mean and median are different. Specifically, in a left-skewed distribution, the mean will be smaller than the median. A distribution that looks like this one, with its tail to the right, is called a right-skewed or positively skewed distribution. In this case, the median will be smaller than the mean. Note that the higher parts of each of these distributions represent more common values. So a distribution that's left-skewed, like this one, might have a lot of large numbers and only a few small numbers, such as the numbers in this dataset. The small numbers pull the mean down, but have no effect on the median, since the median is always the number in the middle. A distribution that's right-skewed, like this one, has a lot of small values and only a few large values, like in this dataset. The large numbers pull the mean up, but have no effect on the median, since the median is always the number in the middle. A symmetric distribution, like this one, has most of the numbers somewhere in the middle of the distribution, with fewer and fewer values as you venture farther away from the mean. A lot of people confuse left and right skewed distributions with each other, so the easiest way to remember the difference is to look at the tail. Left skewed distributions have the tail on the left, and right skewed distributions have the tail on the right. Pearson's coefficient of skewness is one of many ways to measure skewness. It can be calculated by taking 3 multiplied by x bar minus the median divided by s. X bar represents the sample mean and s represents the sample standard deviation. The use of x bar and s suggests sample data, but you could also apply this formula to population data, substituting mu for x bar and sigma for s. Pearson's coefficient of skewness will always be a number between -3 and 3. If your answer is not between -3 and 3, then that means that you've done something wrong. Negative values indicate left-skewed distributions, and positive values indicate right-skewed distributions. The closer you are to -3, the more left-skewed the distribution is, and the closer you are to +3, the more right-skewed the distribution is. If Pearson's coefficient of skewness is exactly 0, then the distribution is perfectly symmetrical, with no skewness. Here's the dataset from earlier that I said was left-skewed. I knew it was left-skewed because most of the larger values are clumped together, with only a few smaller values. Oftentimes the skewness is hard to see with large datasets, which is why it's helpful to be able to calculate skewness. To calculate Pearson's coefficient of skewness, we need the mean, x bar, the median, and the sample standard deviation, s. X bar is the sample mean, which is just all the numbers added together divided by 7, since there are 7 numbers in the dataset, which equals 42. The median is just the middle value. Since the data is already ordered, we can see that the median is the 4th number in, which is 50. Don't forget that if there are 2 middle numbers, you have to take the mean of those 2 values to find the median. I'm not going to explain all of the details for calculating the standard deviation, as there are many steps, and we've explained them in detail in a separate video. Here's the calculation for the standard deviation of this dataset, which comes to approximately 24.19. Pause the video and study my calculations, or watch my standard deviation video for more details on how I calculated this number. When we plug into the formula, we get 3 times 42 minus 50 divided by 24.19, which is equal to approximately -0.99. This confirms my claim from earlier that this was a left-skewed distribution, as Pearson's coefficient of skewness is negative. If you run the calculations, you can verify that the middle dataset has a coefficient of skewness of 0, meaning it is perfectly symmetrical, and the third dataset has a coefficient of skewness of approximately 1.61, confirming that it is right-skewed. Alright, my friends, we have finished our discussion of skewness. We will be exploring many more fun and exciting statistical topics that you won't want to miss, so make sure to check out our other videos.